Hello everyone, welcome to MATLAB programming course. Today we're going to start a very important chapter in our class, and it's going to be about matrices. They're so important that chances are you already work with a wide variety of them through your classes or the projects that you've worked. And in addition to that, they're going to be also very important for MATLAB itself, because the MATLAB name comes from Matrix Laboratory, which further indicates how important and fundamental matrices are to engineering field. So it's necessary for us to equip ourselves with proper tools and knowledge to deal with them in our career. Fortunately, in vector chapter, the previous one, we learned a lot about matrices at the same time, because matrices are the vectors in bigger dimensions, and all those techniques that we learned in vector chapter are going to be applicable here, either directly or with a slight modification. So let's start learning matrices. Let me do a short recap on vectors that is going to ease our way into matrices. So we already learned that we define vectors. Vector 1 equals to, let's say, 2, 6, 8, 0, just random numbers, and 1, -1. So I was able to create a vector like that, and if I needed to extract, let's say, the fourth element, what I need to do is just type vector, the name of the vector 1, and the fourth element, I put it inside a parentheses, and this way MATLAB understands that we're interested in 1, 2, 3, and 4. So this was the way that we introduced vectors and extracted the elements. Now we're going to learn how to define matrices. So if I type matrix 1 equals, I open the bracket, and like vectors, I put numbers like 4 and 2 and 7. First, let's create a 2 by 2 matrix. So 4 through, and now I need to tell MATLAB that, okay, this was the first row. I need to go to the second row and complete this next set of information. The way that we do is through putting semicolon. If I put semicolon, as we learned in MATLAB, it means we're telling MATLAB that, okay, it's done, go to the next line. The same thing happens here, but I don't close the bracket to tell MATLAB that that was the end of the information and data. What I need instead is put the second set of data here, and now that I do have a 2 by 2 matrix, I can close the bracket and hit enter. And as you see, we easily created our first matrix in this course. This is going to be a 2 by 2 matrix. Similarly, we can create 3 by 3 matrix. Matrix 2 equals 1, 3, 7. Next line, 4, 8, 1. And now the third line, 9, 5, -2. And close bracket. Now I do have 3 independent set of vectors, 1, 2, and 3. So if I hit enter, if I hit enter, as you see, now we've created a 3 by 3 matrix. We're not, though, limited to creating square matrices, and we can do like that. Matrix 3 equals, now I want to create a 2 by 3 matrix, 2, 5, 8 for the first row, and then 4, -2, and -1 for the second row. And if I hit enter, now you see that it's perfectly fine, and we created 2 rows of 3 columns. And I urge you to go and create larger matrices and explore typing and creating them, because it helps you to deal with many more functions that relates to matrix calculation further in this course. Similar to vector element extraction, now we're going to extract elements out of matrices. So let me clear the screen. I wanted to create matrix number 4 equals, let's create a 4 by 4 matrix. 1, 2, 6, 7, 3. I just randomly put numbers here. 2, and then 9, 6, 1, 0, and the fourth row is going to be like that. Okay, so I created a 4x4 matrix, and now let's say I am interested to extract this one. Well, in vectors, we were able to just tell MATLAB that go to the second one or extract the fourth one, but now we do have two factors or indices to point to a specific element into a matrix. And now if I type matrix open parentheses matrix 4 open parentheses, and let's say we're interested into this 6, so 6 is going to be not first row, not second row, but the third row, and first column, second column. So it's going to be third row and 2, and the second column, so third and 2, because we need two indices to point out to a specific element inside a matrix. And if I hit enter, so MATLAB perfectly knows how to extract that specific information out of a matrix. And always remember that in math on paper, in MATLAB also, we first refer to the rows and second to the columns. The next example, let me extract this one, or maybe this one, number 2. Okay, so if I want to extract that one, it's going to be in the second row and the fourth column. So if I hit enter, I can get this element out of matrix. Let me show you what happens if I put only one index here, one number, like the vectors. You know, we had vectors and we put one element because they were just one set of information. Now if I do that, MATLAB doesn't give me an error. Instead, it returns a number. And if I look at this matrix, I can see that the 1 is the first element. So let me go to 2, matrix for 2. If I hit enter, now it brings -8. Interesting. If I keep doing that, it brings 9. So I understand that by doing this, MATLAB presumes that this is the first one, second, third, fourth, and just give every element a numerical number starting from here and then going to second column and third column. And MATLAB just deals with that like the way that I showed you. It's not very useful or important, but it's good to know that how matrix maps the information and data. Please practice the information that I just showed to you, because then you feel confident typing matrices and do matrix manipulation and other algebraic functions that we're going to learn. See you in next video. Hello and welcome back to MATLAB programming course. In this video, we're going to explore how we can extract range of information out of matrix. So if you remember in vectors, vector 1, let me bring up the vector 1 we worked with. If we wanted to extract a range of information, we could do it like vector 1 equals, let's say we were interested from the second column to the fourth column. So I would simply put 2 colon 4. So if I do that and hit enter, MATLAB just extracts this information because I told MATLAB to extract from the second column up to the fourth column. But how about the matrices? Because matrices do have 2 dimensions. And let me bring up the matrix 1 I work with, or matrix 4, I guess is better. Okay, so now if I wanted to extract information, I do have two dimensions and I need to specify exactly what I'm pointing to MATLAB for every single dimension. The way that we do that is like, let me call it A equals matrix 4, and now I want to extract, let's say, a part of it. Let's start from the middle part. So I'm going to extract this square matrix, so 9, 5, 6, 1, because I was interested into extracting a sub-matrix out of it. And did you remember that it showed you when I wanted to extract information like the vector, we separate the extraction element by column. And this was due to the fact that we had only one row, so we didn't bother to put it here. But here at matrix 4, I need to specify exactly where I'm pointing at. And if you wanted to point out to this submatrix on paper, the normal way that we can do is that, all right, so the first element of this submatrix starts from the second row and ends at the third row, right? Because we always deal with rows first in MATLAB. So it starts from the second row and extends up to the third row. In terms of columns, it starts from the second column up to the third column. So we put it like that. First rows starts from 2, ends to 3, comma, because we're going to extend to the columns right now. So the rows 2 up to 3 and columns also 2 up to 3. And if I put that and hit enter, now you see that MATLAB extracts just the middle part. Let me give you another example. B equals matrix 4, open parentheses. Okay, so 7, 3, 5, 2. Okay, we're interested into this set matrix. And if I want to do that, first I deal with rows. It starts from the first row and extends to the second row. So first up to second. Now we're dealing with columns, comma, and come here, it's third up to fourth column. So third and fourth. And you see that it easily extracts a set of information. What happens if you wanted to extract just this section row? Okay, the rows, we do have 4 sets of them, but we're interested into only starting from, let's start with this one. 8, 5, negative 1. Okay, 8, 5, negative 1. The way to do that is, again, let me call it C and call it matrix 4, open parentheses. And because now we're only dealing with one row, and it starts from the 4th row and ends on the 4th row as well. So the way that we do is call 4 here, comma. And it indicates that we're only dealing with the 4th row. And in terms of column, it starts at second and ends on the 4th. So second up to 4th. And if I do that, MATLAB perfectly extracts this set of information. To do another example, let me call matrix 4 again. And now we're interested to extract negative 8, 9, 5, and this 3 by 3 matrix starting from here. So the lower quadrant here, this part, a 3 by 3 matrix. I wanted to extract that. So again, it starts from the second row up to 4th row. And in terms of columns, stop 1 up to 3rd. That's simple. So if I do that, I can easily extract information out of this. Let me clear the screen. Okay, we'll learn how to create matrices. We'll learn how to extract information out of matrices. But sometimes we need to just change the values in matrices and just manipulate the values. One way to do it is to, let me call it like matrix 1. So if I double click on the workspace here, as you see, if I double click on it, and I mentioned that before, that you can just manipulate the data. For example, I remember, oh, it was not 4, it was negative 4. So I put -4 here and hit enter. And if I just close this part and type matrix 1 and hit enter, now you see that the new value appears here. That's a very useful and powerful and fast way of changing the matrix values. And even I can add 5, 6 and 5, and then I can even extend that 7 and 8. Let me add another row too. So 5, 0, 8, and -124. Okay. So I extended matrix 1 into newer dimensions. So if I do that, and you see that the new values appear here. It's very, very handy for those people who are more confident in Excel-like interface for inserting the value into MATLAB. However, I encourage you to do it manually here, because the more you type, the more you program in MATLAB, the more you feel confident learning it. And, it has a learning curve that is going to be shortened by practice. And one of the best ways to practice correct programming style is to type it over and over again. With that said, I see you in next video. Hello everyone, welcome to MATLAB programming course. In this video, we're going to start trying algebraic functions on matrices. And because we deal with these sort of functions on a daily basis and in our calculations and projects and stuff like that, it's very important to learn how to work with them efficiently. So let's start with the summation. Let me create a matrix called A equals, let's do it 2 by 2. 1, 2, and 3, and 4. Okay, I created a very simple matrix, and let me create another one. 5, 6, and 8, 1. Something like that. Very good. Now I do have 2 matrices, 2 by 2, and now I wanted to add them together. As with the vectors that we learn, in order to do algebraic functions on matrices, they need to be the same size. If you remember, we couldn't sum 2 vectors which had different dimensions. The same is true with matrices. With that said, let us add A and B. If I do that, MATLAB easily adds the first element of A to the first element of B, and then it creates the summation here. So 1 plus 5, 6, then 2 plus 6 is going to be 8, and bring it here. And the same for the second row. Very simple concept. Okay, so next let me do the subtraction. And again, it's very, very similar to addition. And actually, it is some sort of addition, because the way that MATLAB actually performs this operation is to multiply B matrix with a -1 and then adds the A matrix to that new B matrix. Let me clear the screen. We can also create a 3 by 3 matrix. So 1, 2, 3, 4, 6, 0, 7, 1, 4. So this is a new matrix. And let me add another one too. 6, 5, 1, 9, 0, 9, 0, 5, and then go with 8, 2, 5. Something random. I think I made a mistake here. Okay. So if I do that, now I do have 2 sets of 3 by 3 matrices. Now I can add them, C plus D, and also C negative D. I can easily do that, but I cannot do the same with A plus C, because they had different dimension, and MATLAB is trying to tell you that matrix dimensions must agree in order to do that. Let me clear the screen. Now let's try to do the multiplication. Let me bring up the matrix A. So I can type any number like 4 multiplied by 2, by a, and MATLAB just performs the operation, or -1 multiplied by a. Very, very easy. And even we can do the same with constants like pi multiply a. So a new matrix is created. The way the MATLAB performs is to multiply this constant value into a matrix and just get the result. We can do the same with b as well. So let's do c. We can do c multiplied by 1/4. So any constant is just valid, and we can do that. And we can do sqrt of a big number like that, then multiply by pi, then multiply by -3. Let me do it symbolically. Symbolic -3/9, not 9, 8 is better, and then multiplied by d. So if I do that, MATLAB easily just performs the operation and just return it symbolically like that. So my point is that you can do all sort of information and just create what you want. And if I wanted to change that, I can do double ands. And now, so we put home. You might ask, how about the complex numbers we learned? So one of the main goals of this course is to use whatever we learn in future chapters as well. So I think it's a good point to just practice the complex numbers in matrices as well. Let me bring up the C matrix like that, and I can easily type I, which is a complex number, only the imaginary part, multiplied by C. And every element in that is going to be a complex number. And I can also multiply 3 minus 8i, then multiply by, let's say, C. And if I do that, now all the elements in matrix, the new answer is going to be a complex number. And MATLAB has no problem because it deals with the whole complex number as one single constant and multiplies it to the whole matrix C. This is one of the points that you can double click on answer here, and if your matrix is complex or it's a big number, it's easier to just manipulate it here instead of just doing it directly in workspace. So I can do like turn this one into -12 and this one to 5, and if I do that, I can return the ants, and now you see that it's now turned to -12 and this one to 5. In this part, we'll learn how to deal with matrix algebraic functions, and please do some calculations yourself, create different matrices, and like use hyperbolic function, trigonometric functions, and just mix it with complex numbers, show the result in different format, and just try to familiarize yourself with different concepts throughout this course, and that's one of the best ways to learn MATLAB. Also, I would strongly recommend that each part that I teach you, you open up the MATLAB help and explore further what examples are available there and what can you learn from those examples. Chances are you learn a new function that will help you to create better and more efficient results. Thank you, and I see you in next video. Hello everyone, welcome to new video of MATLAB programming, and in this session we're going to explore more the matrix multiplication function, because it's very fundamental to engineering field and data manipulation. With that said, in previous video we learned how to do the matrix multiplication, but there are times when you need to multiply matrices element by element. And if you remember, we covered this feature before in vectors, but because it is important. Let's explore that here in matrices as well. Let me start by giving you an example. Imagine that we have a class of 16 students, and we wanted to record their presence in class in 2 days. So the first day, we want to see from these 16 students how many were present. And on the second day, we wanted to see how many students were present on the second day. So if the students are present, we indicate that by 1, and if they're absent, we indicate that by 0. Therefore, let me create the class. So I call it class equal class first day equals 1, 0, 0, 1, 1, 1, 1, 0, 0, 1, 0, 1, and the last one, 1, 1, 1, 1, 1. Okay, so the class first day, it means that the first student was present, the second one was present, the third one was absent, 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 this way. So this is the first day presence matrix. And the second day, we call it class second day equals 1, 1, 0, 0, 0, 1, 1, 1, 1, 1, 0, 0, and 1, 1, 1, and 1. Okay, so this is also the class on the second day. So the students were like present that day as well. Some students were present and some were absent. Now what we want to do, we want to see how many students and which ones were present the first day and the second day. We know that if we multiply these two matrices, let's do it actually. So the class first day multiplied class second day. If we do that, you see that it returns a very different result because it just performs the routine and the normal multiplication of matrices. What we are after though is multiply these elements, these matrices, element by element, so we can see which ones were absent and which one were present, because 1 multiplied by 1 is going to return 1, which indicates that the same student, because this one is exactly the same student as this one. So this way we can understand that which students were present and which students were absent. In order to do that, we need to do the multiplication element by element. So the way that we do that is by, let me clear the screen first. So we can say class, or I can double click it here. So the class the first day, the class the second day. Okay, so I return these. And now what I do is class first day dot multiply. If you remember, putting dot before the algebraic function makes that into an element by element multiplication. That's something that really we want. So class second day. So the class second day, and we put dot in multiplication. Now if I do that, you see that the result now shows that the first student were present the first day and the second day. And we can just see that these students were either present the first day or the second day, but not both. This type of multiplication is not as frequent as the normal multiplication, but there are times in engineering field that you need to perform such activities, and it's good to know that you're able to. Let me clear the screen. The next example that I'm going to show you is very useful, and there are a lot of times that you need to perform this operation, and I feel that it's a perfect time to explain it. What we're going to do is to find the summation of all elements in a matrix. If you remember in vector, let me create a vector called 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so I created a vector with 8 elements, and if you remember in vector chapter, we learned that there is a function called sum, and what sum does is when you pass a vector into it, what it does, sorry, I misspelled it. So if I return the name of the vector into some function, what it does, it creates a single number which happens to be the summation of all elements, right? Okay, how about when we have a matrix? So let me create a variable called matrix and put a matrix in it, 1, 2, 3, 4, 5, 6, and 7, 8, and 9. Okay, so I created a matrix 3 by 3 matrix, and I need to know how to find the summation of all elements. Let's try the sum function here and see what happens. If I say matrix, and if I pass that, you see that we only have, and as you see, we don't get one single number. Instead, we receive 3. And if we look closely, we see that this 12 is the summation of 1, 4, 7. This 15 is the summation of 2, 5, 8. And the same with 18. So what MATLAB did here is to return the summation of all columns respectively. So the sum function did not create the same result as vectors, and that's normal because we're not dealing with vectors, we're dealing with matrices. But there is interesting result here. If you look at if you pay attention here, if you look closely, you see that the answer now is a vector indeed. We didn't get a single number as here, but we received a vector, and the vector is summation of all columns. What we can do is now sum these 3 numbers together, right? Because we do have a vector here. So if I put sum ands, if I do that, you see that now I received a single number, which is the summation of these 3 numbers and also the summation of all elements here. Therefore, a shortcut to do that is to use sum twice. So sum, and again, sum of matrix, right? Now, and another, okay. So now I do have a matrix, the variable called matrix, and it is a matrix indeed as well. So what I do is to pass summation twice, and look what happens when I hit enter. The result is again 45, the same as the one that we received here. So what I wanted to explain here is that if you want to find the summation of all elements in a matrix, maybe it is 1000 by 1000, you cannot just use a calculator or or type them one by one and then do the summation again to do this. Summation again to find the last result. What you can do is to use this function and find the total summation. Let me clear the screen and give you another one. So I call it A. 1, 2, 3, 4, 5, 6. 5 is good. So 5, 6, 7, 8, and 9. And 4, 5, 8, 1, and 0. Okay. Now I created a matrix which happens to be 3 by 5. Now if I wanted to find the summation, one way is to do the the way that we learned was to do that summation twice. So if I simply pass A into two summations and do it, the result is going to be 68. And if you do it by a calculator out of MATLAB, you see that the result is always that it is indeed the correct answer. With that said, I see you in next video. Hello everyone, welcome to MATLAB programming course. I'm Hossein Tutunchi, and today we're going to learn how to find the minimum, maximum, and number of elements inside a matrix. If you remember, in vectors chapter, we learned that if we have like a vector like that, and if you're interested to find the minimum value among these numbers inside this vector, what we can do is to pass the vector, the name of the variable, into mean function. And what it does, it just finds the minimum value among all these numbers. And the same was true with max. So if I say max vector, what it does, it finds the biggest, the largest number in this vector. But what if we have a vector, instead of vector, we have a matrix? But what if instead of vector, we have a matrix? So let's create one. What I do is, let me come to the first line, and I define a matrix called A. And it's going to be 1, 2, -4, 6, and 8. And the second row, -9, 0, 12, -85, 9. And the third row, let's go with 102, 6, 9, -23. And one more, 76. Okay, so I created a matrix which happens to be 3 by 5, and now I'm going to find the minimum value among these numbers. If I pass the matrix A into minimum function and hit enter, you see that a vector is created. Exactly like the sum in previous video, that the first number is going to be the minimum of this, the first column, and the second one, the second column, and just the vector that we found here is going to be representative of the minimum columns of matrix A. But what if we need to calculate the minimum, and actually not calculate, to find the minimum value inside matrix A? What was the solution when we faced the same problem with summation? We learned that if we pass the summation twice, we can find this, actually the total value of the summation of the whole matrix. Therefore, here also we can pass the minimum twice. So minimum of A, what it does, it first calculates the minimum vector, which is going to be here, and then inside the second minimum, which is here, is going to search through this vector and find the minimum value. And let's see what happens. Sorry, it's the capital A. So if I do that, the return value is going to be -85, which is correct, because if you look at this matrix, you see that the minimum, the smallest number, is -85. How about the maximum? If I say max and max A, do it twice, it goes and searches the whole matrix to find the largest part, which is 102. Let me bring the A matrix again. There are times that we are interested to find the numbers, the number of elements inside a matrix. So I want to know how many elements are inside this matrix A. We learned that the size can, what it does, it returns the dimension of the matrix. And if we multiply the dimension, we can find the elements inside it. But you know what I need is to find the elements through only one function. There is actually a built-in function inside MATLAB called normal. So if I say normal and open parentheses, pass matrix A, what it does, it simply calculates the number of the elements inside matrix A with just one function. So what we learned today, let me recap that, is that if we do have matrix A here, if we want to find the minimum, we just pass it twice. If we want to find the maximum, we pass it twice. And if we want to find the whole number of elements inside matrix A, we pass it by normal. And MATLAB just finds the number of the elements. Thank you very much and keep practicing. I see you in next video. Hello everyone, welcome to MATLAB programming course. I'm Hossein Tutunchi, and today we're going to explore the matrices in more detail. One of the areas that we need to learn in matrix algebra is to create bigger matrices by combining smaller ones. So the way to do that, let me create a matrix. Let's do it 3 by 3 for now. Okay, so I created a matrix which is 3 by 3, and then let me create another one which is 2 by 2. If I want to combine these two matrices to build a bigger one, what I can do is to put A and B. And if I do that, you see MATLAB gives me an error which represents the inconsistency of the dimensions in matrices. And actually MATLAB is not going to expand this B matrix with additional zeros just to augment it into a 2 by 3 matrix, so we can expand this and augment it with A. Therefore, please pay attention that in order to be able to combine matrices together, we're required to check the dimensions first. The way that we can do, if we create another elements here, now we do have a 2 by 3 matrix, and I now easily can combine these two matrices like that. Therefore, while performing matrix calculation and matrix creation, always be mindful of the dimensions because they can easily create errors. Hello everyone, welcome back to MATLAB programming course. Today we're going to learn more about the functions and their effect on matrices. Let's start by creating matrix. We do have matrix A. Yes, okay. So we have created matrix A here, and what I want to do is to find sine of A. And if you do that, you will notice again sine, as we learned earlier, whatever comes inside the parentheses is going to be in radians. So MATLAB always performs in radians. This is 1 radian, 4 radian, and stuff like that. Therefore, MATLAB calculates it easily. We can do another hyperbolic function and get the same result. We can come up with matrix B, so it's B. B is like that. So let's do cosine of B, see what happens. You see that MATLAB has no problem calculating that. Another function that we frequently encounter in matrices is square root. So as we learned, we can calculate the square root of A, and let me bring A here as well. So square root of 1 is 1, square root of 4 is 2, and square root of 6 is 2.4, and so on and so forth. However, in MATLAB there is another function, square root, which is specifically designed for matrices. In order to do that, you can type duck sqrtm. So instead of sqrt, now we do have a sqrtm, and if you do that, it's a matrix. M stands for matrices. So if I do that, you can see that there is a definition. Sqrt of A is the principal square root of a matrix. X by X equals A. So I wanted to know what are two other matrices that if I multiply them together, I can find the matrix A. So let's try that. If I say sqrtm of A, I get matrix which is complex now, and let me name a value for it. I name it R, sqrt of A, sqrt of M. Now I do have matrix A, which is the square root of A. Now what happens if I multiply R with itself? You know, it's a square root of matrix A. Therefore, if I multiply it once more with itself, it should create the original matrix A, and it does. If you look closely, you see that they're imaginary numbers, but they're all 0, right? So we came up with the same original matrix A. If I type matrix A here once more, you can see that now they're identical. As we learn, 2 multiplied by 2 equals 4, and this one, the same, is true with sqrtm of A. So how MATLAB interprets this function is that what are those two separate matrices that if we multiply them together, it's going to create matrix A. And this is the result. Let's do it with B as well. So what is B? Sqrtm of B. And you see that there is an error which indicates we're only able to perform such action on square matrices. So if you ever wanted to use the sqrtm of A or any other matrix, please make sure that your matrix is a square one, else there's going to be an error. This is not as common as sqrt of the matrix, but there are special applications where we need to do that. Those studying in control engineering field frequently use this function. Let me clear the screen. So I do have matrix A, and we do have the same concept with exponentiation. So if I put exp of matrix A, and MATLAB just easily calculates the result. However, there is another function in MATLAB which is specifically designed for dealing with matrices when going to and the function is exp of matrix A. Now if I do that, you see that a new result will appear. And just to give you a short introduction with this one, this is also known as phi matrix, and it is very fundamental in probability, in control engineering, and we can easily find the response of a system, including the transient and the steady state responses, by calculating only this function. So it is really important. It has a special use, but there are times you need to use the exponential function for matrices. The same is also true with logarithmic functions. So if I put logarithmic A, it just goes and calculates logarithm of each each element. Let me clear a screen and put A here, and then log of A is going to be calculated one by one correspondingly and put it here. But there is also another function called log M of A, and if we calculate that, there's a warning, just ignore that, but you see that a new entity is just created, which is totally different from what we got here. And I wanted to emphasize that the whole story here is that if you're dealing with matrices, so there are special functions for them designed in MATLAB, and be aware that if you calculate the normal functions, they're going to produce different results than those functions specifically designed for dealing matrices. It is a very important point to remember. Let me clear a screen for the last item here. What if we wanted to raise the matrix, raise a number to a matrix, like 2 to power A? We do have a matrix, we do have a number, and we want to raise it to a matrix. So if we do that, MATLAB easily calculates the result. These functions have special usage, and be sure that you're mindful of that. Be sure that you know where to use them. For example, if you wanted to do it element by element, which is more frequently used, we can put it like that, as we learned with dot. It indicates that each element inside A is going to be raised. Please note that we do have a different notation when we raise the matrix to a power, like this one. So let me clear the screen. This is A, and what if I wanted to raise the matrix to power 2? So if I do that, you see that a new result, which is also a matrix, is created. But the answer is not really relevant. It doesn't make sense that 1 to power 2 is going to be 27. Again, remember that we do have element by element multiplication, division, subtraction, and power. So if I do that, now you see that 1 to power 1, 1 to power 2 is 1, 4 to power 2 is 16, 6 to power 2 is 36, and so on and so forth. The beauty is that whatever we learned so far is applicable to newer functions, to newer matrices, algebraic functions, and whatever we learn, it is just interconnected together. We need to practice using them together so we feel confident while we're dealing with programming. Thank you very much for watching this, and I'll see you in next video. Hello everyone, my name is Hossein Tutunchi and welcome to MATLAB programming course. Today we're going to learn more about a special set of matrices in MATLAB known as special matrices. And they're called special because they do have specific use in engineering. The first one, which is frequently used, is zeros. So the way to create matrix zeros, and you can guess what it does, it asks for a number. Let me put 2. And if I do that, it creates a 2 by 2 matrix which all of its elements are 0. And we can easily create 5 by 5, or even bigger. And one of the use of these, when you wanted to create a big matrix and there are only certain elements of this matrix is going to be filled, it's better to create a zeros like this one. Let me create one like that, 7 by 7. And then let me actually put a name for it. Let me put it A zeros 7. And now if I come to here and double click on it, I do have the values here. For example, I wanted to create a new value for it. How about here? 1, 43, -6. So by doing that, if I call the matrix A, now it is the revised value just appears, and you can And you can tell that by doing so, you can create the desired matrix much faster. Let me clear the screen. Another important function that we use a lot is ones. So ones, and again, it requires for a number. So we put 2. Unlike the zeros, which only creates the 0 values, it will create ones. So I put ones 5, and so a matrix will be created. You might be asking that, is it always going to be the square matrices? And the answer is no. You can create zeros of 3 and 4, which is perfectly fine, or ones of 2 and 5, which is again 5. Let me clear the screen. Another special matrix that we need to know is a diagonal matrix. One specific matrix is very well known in engineering field, and it is called the identity matrix. The way that we create identity matrix in MATLAB is through a function called I. If I put I and MATLAB asks for a number, I can put 4, and look what happens. If I do that, a matrix will be created, which first of all is a square matrix, and second of all the diagonal elements are 1, and all the other ones are 0. This is the definition of the identity matrix. Similar to ones and zeros, I matrix can also be different than a square matrix, like this one. So if I do that, you see that MATLAB tries to create the I matrix as long as possible, because this is the definition of the matrix A. But because it's not a square matrix, MATLAB is not able to create it, to make it a square. We can also put it like that, and you see that MATLAB just tries to create it to create a matrix as close as possible to identity. Let me clear the screen. One specific characteristic of the identity matrix is that when it's multiplied to any matrix, the result is going to be that matrix, the original one. Let me show how does it work. So if I have, let's see what's A. It's a big one. Let's go with B. Okay, so we do have a matrix B, and if I multiply it by I, so B multiplied by I of 4, you see that the dimensions does not agree. And it's very important to note that even special functions like I should match in dimension. So what is the dimension of B? The dimension of B is 2 by 3. So if we can create an identity matrix which is 3 by any number, we're able to do the multiplication. So let's create one. I have 3 and let's go 5. How about that? So it creates this matrix, and now if I multiply B multiplied by I, 3 and 5, you see that now the multiplication is possible. But the dimension of the result is not the dimension of the B, because the B matrix is this one. But now we do have 2 additional columns. The reason being is that we're only able to claim that the result is going to be the original matrix when the identity matrix is a square. So let me clear that. If I do have a matrix called B, which is a 3 by 3 matrix, like that, and I create an identity matrix called let's make it 3 by 3, like that, and if I multiply B to I, multiply them together, you see that the result is going to be matrix B. The original matrix is always true. So if you multiply any matrix with identity matrix, which is a squared one, the result is going to be always the original matrix. Let me clear the screen. Another matrix that I would like to introduce to you is the magic matrix. So the magic, it just receives one number, and I put 3 here. So if I do that, magic 3, and I hit enter, you see that a new matrix is created, which is 3 by 3. And what is the magic number? Let's ask MATLAB. So if you search that, the magic returns an n by n matrix constructed from the integers 1 to n squared with equal row and column sums. Equal row and column sums. So what is the magic is that if you add the row elements and the column elements of this matrix, the result is going to be the same. Let's try that. What is the sum of the first row? Therefore, if we add 8 plus 1 plus 6, the result is going to be 15. Let's try this one. 8 plus 3, 11 plus 4, it is 15. How about the second one? So 1 plus 5 plus 9 is 15. And this one, 4 plus 9 plus 2 is also 15. Therefore, the summation of all elements in this matrix, therefore the summation of the rows and columns of this matrix for any specific rows and any specific column in this matrix is going to be a same number. It's called the magic number. There are also other special matrices which are not frequently used, so I leave them to you. So if you like, you can search the MATLAB for special matrices, and there are a couple more that you can explore. Hello everyone, welcome back to MATLAB programming course. Today I'm going to show you how we can calculate the transpose of a matrix, which is very important. There are a lot of areas where we need to find a transpose of a matrix in order to get the result. So let me show you how we can do that in MATLAB. Exactly like vectors, when we had a vector, let me create one. Here we do have a 1 by 5 vector, and I showed to you that if you wanted to calculate the transpose of a vector, the only thing we need to do is to put a single quotation exactly after the name of the vector. And if we do that, we can come up with a 1 by 5 vector. The same holds true with matrices. So let me clear the screen. I put A equals 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10, 11, and 12. So now I do have a 3 by 4 matrix, right? So if I calculate the size of A, it's going to be 3 by 4. Now, if I want to create the inverse, what I need to do is put, let me call it B also. So what I need to do is to put A transpose, right? I put B, a new matrix, which is the transpose of A. And if I do that, you see that we create a 4 by 3 matrix. So size of B is now 4 by 3. Therefore, exactly like vectors, the way to calculate the transpose of a matrix is through employing single quotation. Let me clear that. Another important feature we need to learn is, let me create a square matrix. I'm just trying to create a, let me make it different. So, okay, I think it's okay. Now I created a square matrix which is 4 by 4. Sometimes we need to extract the diagonal elements of a matrix like this: 1, 6, 5, and 2. So I'm only interested on the diagonal elements. The way that I can do that is through a function called diagonal. So diagonal of matrix A simply calculates only the elements on the diagonal. So we could easily extract that. And if you need it in a 1 by For vector, what you can do is to put n's like that and calculate it. It's always better when you extract a part of a matrix, you make a name for it. So for example, it would be better if I put d equals diagonal of A. So now I can put the transpose. So it's easy to calculate the diagonal elements, and they're very important, especially in some areas like control engineering, because it enables us to calculate the eigenvectors, eigenvalues, and other important features. Okay, so let me clear that to start the next item. There are a lot of times when we need to just extract a portion of a matrix. Let me bring A here. Okay. So what if I need only the upper part? So if you look at it, it's a square, and I can divide it imaginarily by just drawing a line on the diagonal to make it upper and a lower division, right? So if I draw a line on the diagonal elements, they're going to be divided into upper and lower. What if I was interested into extracting the upper part of a matrix? How can I do that? If I cut the upper part or the down part of this matrix into half, it's going to be a triangle. So I can use a function triangle, and now I need to specify whether it's upper part or the below part which I'm interested. Now let's go to upper part. And if I do that and pass A to it, you see that the new matrix which is created is all the elements below the diagonal element the diagonal line is going to be 0, and the upper part is only left. So it's like that. We only extract the upper part of this matrix and put everything else into 0. We do have a very similar option on lower elements of the diagonal. So let me do this. We can extract the lower part by try low and pass the matrix. So if I do that, now you see all the upper parts are assigned to 0 and the lower part is left. If I want to give you an example where we use these, we all had numerical analysis courses where you were asked to find the values for 3 variables numerically. And later in project section, I'm going to use all these features and show you how useful they are in programming field. So today we'll learn how to extract the diagonal elements, the triangular upper part, the triangular lower part of a matrix, and also the important function of transpose. Please keep in mind that you need to practice all these functions in order to instill the MATLAB programming skill. So far, you've done a great job, and I will see you in next video. Hello everyone, welcome back to MATLAB programming course. This is Hossein Tutunchi, and today I'm going to show you how useful MATLAB programming is in calculating time-consuming problems and calculations. We all had a numerical analysis and just algebra courses that we were required to find the solution of system of equations. And you know, it's not hard, but it's time consuming and it's not the best of the feelings. So let me tell you what's the story. Let me create a matrix. Let's call it A equals 1, 4, -3. And the other one is 6, 2, and 8. Okay, so I created a matrix like that. What I actually mean is this one. So the whole system of equation was like x plus 4y equals -3. Okay, so the first line I represented this way. And the second one was 6x plus 2y equals 8. So you were asked to solve the system of equation like that, and we can represent the the system of equation in matrix format, which is called the augmented form, because the first 2 by 2 section of the matrix represents the variables and the coefficients of the variables, and the last two parts represent the values. So let me write the matrix A here again. Sometimes you were asked to find the values for x and y, so the equations are satisfied. There are different solutions for gaining the result, but today I'm going to show you one of the easiest ones, which is called the reduced row echelon form. And if you want to further investigate that, you can type doc RREF. RREF, and if you hit enter, you see that RREF, you can read the definition and what it does, but I'm not going through that just to complicate things. I'm not going through that because it just is going to make things more complicated here on the definition, but what I'm gonna do is to show you how useful the whole thing will be. So with that, I can type RREF and pass the matrix that we were working on into that function. And look what happens. If I do that, you see that the MATLAB just solves the equation for you. There is a 2 by 2 matrix here. If you imagine like a line separating these two, so the 2 by 2 is a diagonal matrix with 1 on the diagonal parts and some results. And the way that you can read it is x equals to 1.727 and y equals negative 1.1818. How easy it was. Just by typing one function, we were able to solve the equations. Let me show it to you by doing a 3 by 3 matrix. So I clear that and I put B equals 1, 3, negative 2, 5, 6. It should be 4 by 4. So 5, 6, 4. Excuse me, it should be 3 by 4. So this one and 1, negative 12, 8, and 2. That's it. So now I created a matrix, and the way that you can read it is 1x, 3y, minus 2z equals so on and so forth. Now I want to find the values of x, y, and z that makes the whole set of equations satisfied. The way that I can do it is R, R, E, F of matrix B. So if I do that, MATLAB easily calculates the result. Now you can find that z value is negative 2 and y value is this and x value is this. It's really, really fast and super easy to calculate the results using MATLAB. Thank you very much, and I'll see you in the next video. Hello everyone, welcome back to MATLAB programming course. So far we learned a lot about matrices and vectors, and the reason that we're working on these topics is that the programming is dealing with all these features and how you can manipulate the functions in MATLAB to get the results, and there are always different ways to do that. So it is necessary for us to expand our knowledge in MATLAB, so in case that we are presented by a different sort of problem, we have some idea how we can approach that and actually solve it. Today I'm going to introduce you more of the matrix functions, which are really important. Let me clear the screen, the variables. I'm going to define a new matrix. So I define a new matrix. I'm sorry, I put Okay, so I defined a 3 by 3 matrix, and now I'm going to calculate the trace. In this video, I'm not going to explain about the mathematical aspects of the things because this is not the purpose of this course. However, I'm going to show you how you can calculate different results which are related to matrices with MATLAB. So the trace, if I do that, it's 6, and what is the trace is the summation of all the diagonal elements in a matrix. We do have 1 plus 5, the result is 6, and it is the diagonal summation known as trace. The next one is rank. So rank of A, it's also very important. You can pass it through the function called rank, and if you hit enter, you see that the rank of the matrix is 3. It's especially useful when the matrix is not diagonal. So let me come to the first line and define a new function. 1, 2, 3, 4, 5, negative 1, 3, 9, and 3, 1, 9, 8. Okay, now I created a 3 by 4 matrix, and as you see, it's not diagonal. Let me calculate the rank of B, and you see that the rank is 3. If you're interested to further explore the meaning of the rank in matrices, you can also visit the MATLAB documentation, which explains every function in more detail. Let me clear the screen. Another important value we need when we're dealing with matrices is the determinant. And the way to calculate determinant is to pass the matrix into det function, which stands for determinant. And now, because we need a square matrix, you cannot calculate the determinant for those matrices which are not square. So I do happen to have a square matrix I defined here, A. Let me type determinant of A. And if I do that, you see the determinant is going to be negative 24. If you have tried to calculate the determinant of a 2 by 2 matrix, it's going to be, easy and almost fast. But when it comes to a 3 by 3 matrix, it's going to be really time consuming. However, there are tools like MATLAB that makes this task super easy for you. To show you that the math determinant is only calculated with square matrices, let me calculate the determinant, the B, which is not a square matrix. If I calculate, you see that the error defines matrix should be squared. Let me clear the screen. The next important thing I wanted to show you here is inverse. So I do have matrix A, and I wanted to calculate the inverse. The way that we do that is through using INV function. INV of A just calculates the inverse of A. That's simple. How about B? If you do that, you realize we're not able to calculate the inverse for a matrix which is not squared. In this video, we'll learn how to do the rank, how to do inverse, and also the trace. I hope you enjoyed the course, and I see you in the next video. Hello everyone, welcome back to MATLAB programming course. I'm Hossein Tutunchi, and this is going to be the last video of matrix chapter. In this chapter, we learned a lot about matrices, and we used very useful and actually the most important functions in matrix manipulation. And I am going to end the chapter with a very important topic on symbolic matrix calculations. The reason being is there are a lot of times that we are not working with numbers. We're dealing with symbolic calculations. We're dealing with variables. And therefore, we need to know how to work with MATLAB and solve the matrices symbolically. Fortunately, MATLAB is equipped with symbolic toolbox, and we're going to cover the matrix calculation symbolically today. So let me define our variables, seems x, a, and b. These are the variables that I'm going to work. Let's define a 2 minus x. I'm creating a 2 by 2 matrix, by the way. 3 x cubed. And for the second row, let's go with 4x squared minus 3x and 9x squared plus 9x squared and plus 2. So this is going to be matrix A. And if you look closely, you see that MATLAB shows the symbolic matrices differently than what we learned, and also commas are used in order to separate elements. So let me calculate B. 2x minus x cubed 8x plus 1, and the second row is going to be x minus x cubed and 5x plus 8 8x cubed as well. Okay, so I created two matrices which are 2 by 2, and as you see, there are no numbers in there. They're all symbolic, and I'm going to show you that it's really easy for me to calculate, for example, the inverse of A. MATLAB has no problem to calculate the results symbolically, and also we can pass the pretty ants, and MATLAB just can show it very beautifully. Also, we're able to calculate the multiplication and pretty ants. Just the multiplication is shown, and all the parts that we learn throughout the course, we can just subtract them. We can make the summation like that. And as you see, we could get the results very easily. And let me clear the screen. We're able also to perform element by element calculation, and MATLAB is able to create the results very intuitively. We're also fully able to investigate all the parts and all the functions we learned, like transpose, inverse of x, inverse of A, and just finding the trace of B. We're fully able to do that. And like the determinant, one of the most important ones, we can do that also for B. And as you see, we are really comfortable with any sort of calculation in MATLAB if we know how to deal with it, how to approach it using the right tools and functions that we learned. I hope you've learned a lot throughout this course, and don't forget to practice, because that's what really matters and will make you a proficient MATLAB programmer at the end. As we progress throughout the course, we get closer and closer to programming parts where we need to use all the things we learned here to make functional programs. Thank you very much, and see you in next chapter.